Hello, I've had a question in the 4U Physics, Unit 1, Lesson 6. Spot the wonder cow, question 48. Always had a soft spot for spot. So, for some reason, we strapped rollerblades on her, only in the physics world, and a rocket pack, and standing on the bottom of the hill at an incline of 20. So I'm going to go ahead and draw that. And of course, I am not going to draw the cow. I'm just going to draw a dot since I have a hard time drawing straight lines, let alone a cow. So Spot's rocket pack provides a force of 2,000 newtons. Now, because Spot's pointed up the slope, the applied force is going to be 2,000 newtons up that slope. We know her mass, and we want to know how long it'll take to reach the top of this hill that is 250 meters in length. So, using our diagram, free body diagram, we have force due to gravity is in this direction. Remember our normal force, perpendicular to the surface. It never indicates the coefficient of friction, so the assumption here is because she's on rollerblades, it's frictionless. So the only thing that is working against her is our FGX. So this allows me to then construct my algebraic equation, and it all stems from FU ma. So our unbalanced force. So it's our applied or driving force minus any frictional forces. And in this case, it's only FGX working against her. Mass times acceleration. So it's going to be a straight 2,000 newtons. We don't have to calculate it with sine 20 or cos 20 or whatever because she's pointing the rocket up the slope. Minus, now our FGX, force down the slope. It is her mass, gravity, and sine theta equals ma. So, just double checking our information here, we should have everything. So we have 2,000 minus 250 times 10 sine 20 equals 250a. So, turning to my calculator now, we have the 2,000 minus 250 times 10 times sine 20. And I get 114, let's call it 45 equals 250a. So divide my answer by 250. So her acceleration from that rocket pack is 4.58 meters per second squared in the forward direction. So now we have an acceleration. This allows us to return back to the question and use our kinematics formulas. So the assumption here, the inferral, is that she's not moving off the start. Don't know V2. Don't really want to know V2, so I'll skip that. We know delta D is 250 meters. We now know her acceleration to be 4.58 meters per second squared, and these are all in the same direction. And we're looking for time, so T is the unknown. So going through our kinematics equations, we know that delta D equals V1T plus 1/2 AT squared. Nice thing about this, because V1 is 0, don't have to use a quadratic formula, so that T is gone. So we end up with 250 equals 1/2 10 T squared. So 250 divided by 0.5 divided by 10. And the root of that gives me 7.1 seconds. All right, so there we go. Now, if I recall, so therefore, Spot takes 7.1 seconds to get up the hill. If I recall, I think the answer in this one in the sheets is actually wrong. I think they have like 17 seconds or something like that. And I don't know whether it is a typo in the sense that they wanted 7.1, they typed 17, or they had some different information than what we had when we worked it out. But anyway, that is the correct process and the correct answer. If you have any questions specific to this, let me know, and I'll see if I can clear them up.